So let's now look at the types of chemical reactions. Because when we're looking at chemical reactions, there are 6 major types of reactions that we're going to look at. These 6 types of reactions come from the patterns associated with the reactants and the products. So we're going to study these patterns to be able to predict our product. And in chemistry, what we really want to be able to do is take 2 reactants, 2 or more reactants, and be able to predict what we're going to get. And science is all about prediction. Well, the first type of reaction is the easiest type. It is called a synthesis. And a synthesis reaction is when we have 2 or more substances and they combine, they synthesize into one. We can start with either elements or compounds, and what we always have to remember is we have to follow the rules for formula writing, balancing charges where necessary, balancing chemical formulas. So let's start with an example here. And here's our first example, NaCl. Now notice NaCl, we are combining 2 elements together, Na and Cl. And if we combine these 2 together, they are going to combine together to become one, NaCl. Now we have to look at the charges to balance the charges. Sodium is a +1, calcium is a -2, so it would just be NaCl. And if we balance the chemical formula, we'd have 2 Na plus Cl2 gives us 2 NaCl. So that's our first type, a synthesis reaction, 2 becoming 1. Well, the opposite of a synthesis is a decomposition, something breaking apart. And a decomposition is one substance breaks down into 2 or more products. Now these products are simpler. They're either elements or simpler compounds. And here's an example, H2O. Now notice this is one substance. We have just H2O. And this one substance is going to break apart into 2 simpler products, hydrogen and oxygen. Remember, they are diatomic. And if we were to balance the chemical reaction, we'd need 2 water molecules to give us 2 hydrogen and 2 oxygen. So decomposition, breaking something apart. All right, let's look at the next one, single replacement. And a single replacement reaction is when an element reacts with a compound. And that's very, very important. An element reacting with a compound. So make a note of that. When this occurs, the element replaces one of the elements in the compound. There's a replacement. If it's a metal, it replaces the metal. If it's a non-metal, it replaces the non-metal. So in a situation like this, notice we start with an element here of Fe and a compound. And what's going to happen is the 2 metals are going to replace each other. And what happens when they trade spots is we get this. The Fe combines with the SO4. Notice they have trade spots. The Fe and the Cu have swapped. They have replaced each other. That is a single replacement. Well, a double replacement, very similar. The key to a double replacement, though, is it's 2 compounds. So make a note of that as well. 2 compounds. Single replacement is an element in a compound. 2 compounds is a double replacement. And in a double replacement, 2 of the compounds replace each other. Now, the new compounds we have to remember are balancing of charges. The positive and negative ions must balance. We must follow all our rules for formula writing. So here's an example. Imagine we have CaCl2 and Na2CO3. We have 2 compounds. And what's going to happen in these 2 compounds is the metals are going to swap with each other. Or we could think of it as the non-metals are going to swap with each other, whichever way you like, and they just trade partners. They double replace each other. So what was once with the Ca now goes with the Na, or vice versa. There's that replacement, a double replacement. Now we have to look at the charges to balance the charges, and that would give us our chemical formulas. And then to balance the chemical formula, we would need 2 NaCl2 sodium chloride to balance that chemical reaction. Well, let's look at the next one, an acid-base neutralization. We've already talked about acids and bases. What we want to recognize is this is really just a special kind of a double replacement. Special because we're dealing with acids and bases. And remember, when we started dealing with acids and bases, we were talking about H plus and OH. So our acid will always have an H plus and an OH from the base. So together, they are going to neutralize, and they're always going to form H2O, water. That's what makes it that special kind of reaction. Well, here's an acid-base example. Notice we have an acid starting with an H, a base ending with an OH, and we're always going to end up with water on the other side. So over here, our compound that's going to form is always going to be water, and whatever's left over, the Br and the Li combine together to give us the salt. There's our acid-base neutralization. Well, there's one last type. This is our favorite type, combustion. We get to burn things. And combustion deals with the burning of hydrocarbons. Now, anytime we are burning something, we always have oxygen gas. Oxygen is what we're looking for. So anytime we have oxygen and we have a hydrocarbon, we're going to get this burning. And here's the other reason we like it. This is the easiest one. We always get 2 compounds, and those compounds are always the same, carbon dioxide and water. So here's an example, CH4. Notice it's a hydrocarbon combining with oxygen gas. As soon as we recognize its combustion, we know we're going to end up with carbon dioxide and water, and then it's just a matter of balancing the chemical reaction, and there's our balanced equation. So it's CH4 plus 2 oxygen is going to give us carbon dioxide and 2 water molecules. Now, being able to recognize these patterns allows us to predict, and we really want to be able to predict the products in a reaction. So given the reactants for a reaction, you're going to have to determine the products that occur. And we want to be able to follow those patterns. Now, what's challenging about this is this requires an understanding of the types of reactions, what we've just looked at, writing chemical formulas, which we did in chapter 6, 7, and a little bit in chapter 8, and then balancing chemical equations, what we did earlier in chapter 9. All of this comes together to predict the products and write a balanced equation from those predicted products. Now, knowing these predictions and following these patterns, very, very important. What you want to do is in your textbook on page 245, or if you want to just pause and write this down, you can. This doesn't appear in your data booklet, so you want to make a note of this, of the general forms. Synthesis, 2 things becoming 1. A plus B combines into AB. Decomposition, 2 things together, AB together, split apart into A and B. Single replacement, a compound with an element, and the C and the A trade spots, they replace each other. 2 compounds together, AB and CD. Notice A and C trade spots with each other, AC. Special type of reaction. Acid-base, starting with an H, ending with an OH. We end up with HOH or H2O and some type of salt, and then combustion, burning, CH with oxygen, always giving us H2O and CO2. So being able to predict these products is very, very useful and very, very important skill throughout chemistry.